Protective relays. Protective relays are the devices which protect power system components like transformers, which are used to step up and step down the voltages to the various levels, transmission lines, which are used to transfer power from one point to another point, bus bar, which is used to distribute the power among various components of the system. Now let us consider a system where the transformer is connected in a substation via protective relay in order to protect it from various faults like an environmental fault or a human-made fault. In our example, we are taking an environmental fault like a rainy condition where the line may break due to the strong winds. This results in a LG fault where the remaining line carried the fault current to the transformer as shown in the figure. Here, protective relay sends the fault and isolates the transformer from the system and preventing it from damaging. This is how this protective relay protects the transformer from damaging. Protective relay protects from various faults like LG, double LG and other kinds of faults. The relay simply works, sends the fault, circuit breaker isolates the component from the system. This is how a typical protective relay employed to protect equipments like motors, transformers and etc. Over current relays. Over current relays are the protective relays which works in fault current region. Generally, when the current is way above the safe current limits, the relay senses the fault and trips the circuit breaker. Overcurrent conditions are the conditions where the short circuit occurs in the system which increases the current. The faults like LG faults are one of the fault conditions. Generally, a overcurrent relay is electromagnetic relay which is said to be current sensitive element. This only responds to the overcurrent and does not respond to the safe current, and this is how they only respond to overcurrent faults. Let us see into the working. There is a overcurrent relay which is connected to a transmission line via circuit breaker. When there is a high current in the transmission line, the current coil gets excited and shorts the contacts, which will open the circuit breaker and isolates system from the faults. In this way, the overcurrent relay protects the transmission line from short circuit current. These relays are said to be triggered only at the fault current conditions which are harmful for the equipments of the power system. Inverse definite minimum time relay. Inverse definite minimum time relay is a type of overcurrent relay which trips according to the magnitude of the fault current, which means as the amount of fault current increases, the relay tends to trip the circuit breaker quickly. Like if I is equal to 35 amperes, the time taken to trip the circuit breaker is 2 seconds. When the current is increased to 50 amperes, the time taken to trip the circuit breaker is decreased to 0.5 seconds. The relay is particularly used in a transmission system where the fault occurs due to the various reasons. So as the fault of the current magnitude differs from different types of faults, the condition of faults relay has to act quickly to react to the system. Here there is a transmission system where the overcurrent occurs. The red line indicates primary circuits, blue line indicates secondary circuits and green indicates the disk. When there is a high currents in the red line, it induces high currents in the blue line which rotates the green disk fastly. This trips the circuit breaker 1 and opens, so the system is protected from the overcurrent fault quickly. This is how a IMDT relay works in a power system to safeguard the operation. There are specialists in acting according to the amount of fault current. As the fault current increases, the time taken to terminate this fault will be decreased. Impedance relay. Impedance relay is one of protective devices which are usually employed to protect line from faults. These are also called as distance relay because their impedance depends upon the length of the line, which means as the length of the line increases, the impedance of the line also increases. A impedance relay is a voltage controlled overcurrent relay, which means the circuit breaker trips is caused by PT through registering torque and CT gives operating torque. Now see, there is a line which is connected to a PT and a CT. This PT and CT sends the voltage and current to the protective device which calculates the impedance and sets it a standard value of impedance. When there is a short circuit, there will be a decreasing in voltage and increasing in current, which will send the signal to the protective device. These calculate the impedance, which is an increased impedance. This increased impedance trips the circuit breaker and opens the circuit. This is how impedance relay works by calculating the impedance between the operating points of the line. The CTs and PTs calculate the impedances by protective relay, which isolates the system to safeguard the operation. Current differential relay. A current differential relay are used in equipments where there need to be a protection when they are connected by two different lines. These relays are generally works when there is a difference in the current carrying from the lines. Like if line A current is different from the line B, then the difference in the current is the operating point of that relay. Let us see how things works in this relay. Here we have a system where the transformer and motor is connected to a differential relay and these two are fed from two different lines. Here in this environment, there is no particular faults right now. If we introduce a fault like a overcurrent fault in these systems, the currents carrying the overcurrent from line A and line B, the differential relay sends the difference in current and sends the tripping signal to the circuit breaker. This circuit breaker opens the connections to the transformer and motor by safeguarding the operations of these equipments since they are costly equipments in the power system. A differential current relay works on a Kirchhoff's current law. They do not bother about the outside faults. They only bother about the faults that occurs at the equipments. Directional relay. Let us see how directional relay works. Let us consider two lines A and B which carries power from into the bus and outside the bus. And when due to the fault conditions in line A like a LG fault, the current travels from line B to the bus and from bus to the line A. When there is a overcurrent in line A, the relay which is a overcurrent relay in line A 51 sends the overcurrent and shut down the power to the line A. Since the current is same all over the line B also carrying the same fault current, which the relay 51 in line B also detects the faults. These will causes the bus without power. Like due to this overcurrent, the both relays tries to shut down the whole system, which left the bus bar with no power to distribute the power to the customers, as shown now. In this condition, we have to employ a directional relay, which will trip the circuit breaker when there is a change in direction, like the direction from bus to the line. Bus to the line is a restricted direction, so it stops the line going. So line to bus B is a good condition. It will allows the current from line B to the bus. In this way, the directional relay works by tripping the circuit depending upon the direction of the faults. Synchronous check relay. A synchronism checking relay provides a contact closure when the frequency and phases of two sources are similar within small tolerance region. Typically, These relays are employed when there is a need for the interconnection between different stations are required. The challenge faces in interconnections are voltage, frequency and phase angle. When these quantities does not matches, the fault not only damages the line but also serious damages to generators, transformers and motors of the system. Let us look into its working. Here there is a two systems. One is a hydro system, two is a thermal system. These two lines should be interconnected through a relay which checks the synchronism between these two lines and sends the signal to the circuit breaker whether to contact the line for interconnection or wait for the synchronism. This relay checks the synchronism at the two ends of the circuit breakers. These relays are employed to know the condition of the system. Generally, they check the synchronism and sends the tripping signal to the circuit breaker. In order to make sure synchronism before connecting any systems, synchronism relays are used.